Okay, so we so we're gonna like be doing this project where I'm gonna use like a fully connected neural net, like a regular neural net, to do sequence prediction. Like a transformer, except like I don't want to implement like attention layers. Um, Actually, I kind of said I was trying to hand implement one, and I got blown up on the multi-headed part. But anyway, so like I'm just gonna do like a fully connected, like a regular like a densely connected neural net, and then we're gonna do sequence prediction, like of I guess language, and and then I'm gonna make like cool visualizations. Like what I want to do is I want to have I guess like a JavaScript app, and like it's just gonna display text, and then we're gonna highlight each character with the probability that the sequence model assigns to that character. Um, and then I wanted to do something like where you would contrast it with like a Markov model. And I don't know why you would do any of that. But anyway, so like that's like what we're doing. And so anyway, so yeah, so okay, so like so from what I understand uh of like how my fully connected sequence predictor is going to work is so we're gonna have like a sequence, like this is a sequence like of characters, and then like originally what I was gonna do is you just like one hot encode each character, and then like you would concatenate all of those one hot vectors together. So but the problem with that is that you end up with like, I mean, even if you're just doing 26 alphabet characters, it's 26 times like the max length of your sequence. And I mean, I guess I could just do that actually. But I think the thing that like most people do is they use like an embedding layer, and so my understanding of that is that like each character maps to like an integer, and then well, I mean, at the end of the day, like you're still using one hot vectors, I guess, for the initial characters, but you have like an embedding matrix which like selects yeah, I mean, you're basically like reducing the dimensionality of the 26. But I guess like you're still using like a one hot vector. But like so you'd have like an embedding matrix, which would be like you pick an arbitrary dimension, so like say 3, and then you would have like 26 columns. And then like so the T, for instance, would map to a one hot column vector, and then like you'd multiply and then you'd end up with a three-dimensional vector. So like the t would map to like a three-dimensional vector, and then you're then like, in this case, you'd be passing into the neural net like 3 times max length. And my understanding is like, oh, also this looks like garbage. Here, I can fix that. Yeah, now it's literal. Also, this is like a matrix. Yeah. Okay. So yeah, how do you do a matrix? I guess you do like dunk, dunk, dunk. Yeah, that's like this. Okay, so this is an embedding matrix, right? So anyway, my understanding from like having briefly looked at like the Keras documentation is that it's supposed to do all of this automatically. So yeah, basically this video is going to be me probably not understanding the Keras documentation and you know, wrestling with the API to get it to do this. Like this is what I want to do, right? Like I want to have strings of characters that will be, so I guess all we're trying to do is I mean, I guess my understanding is like the layer is going to take like this sequence of characters and give you a sequence of like three-dimensional vectors, right? Because like it's internally doing like this. It's mapping it to like an integer or like a one-hot vector, and then it's this embedding layer, or the embedding matrix is like randomly initialized, and then it's doing that multiplication, and then like it's outputting. So like it should output a I guess, I mean basically like a matrix where like each column is the embedding vector for each character in the sequence, I guess. Okay, so like let's look at the documentation here, if I can find it. Cause yeah, so they have like embedding layer, and then they have an example, and this model will take as input an integer matrix. But I think it's like I think we're looking for text. Yeah, I think we're looking for this layer. It transforms a batch of strings into a list of token indices. Yeah, I think that's what we want. Cause I mean it's like see, it's kind of like in their example, they're mapping entire words to integers, and then I think you would pass this to the embedding layer. Would that go to the embedding layer? Yeah, because it takes a integer matrix, and then an integer matrix. Yeah. So I think you need, so I guess you need like the embedding layer and also the vectorization layer. Let's just use the vectorization layer to see what it does. My only concern is that like they're using, like it's tokenizing entire words, and I want it to tokenize individual characters. And it also seems like that should like just be like a default. There you go, you can split on character. Okay, so yeah, I think that's all we're gonna, okay, so yeah. So we're gonna try to run splitting on character. And then see what it does, I guess. So I'm just gonna copy this entire thing. Oh, that's not gonna copy very well. Okay, that's fine. We'll just we'll type some stuff over if I can find my fucking notebook. Okay. Alright, so we need to import. Gotta do that. Okay, and then okay, so we will create the data set sequence length to pad the outputs to data set from tensor slices. So sentence. I'm just gonna put in one sentence. This is a sentence. Wait, does that need, like, what's the dimension on that? I don't know. Okay, whatever. Okay, so then we create the layer. Yeah. Vec layer. tf dot keras dot layers dot text. Whoa, it knew. It knew what I was gonna do. Okay, so like max tokens. I mean, like 26. Like, this is where I feel like I'm not doing this correctly. But max tokens 20. Well, I mean, I don't know. What's the thing? I don't know, because I guess 27 with space. Like, if we remove all punctuation and we lowercase, then you'll have like 27 characters, I think. So yeah, so then we have like options, max token, max size of the vocabulary. This should only be specified when adapting a vocabulary or when setting pad to max tokens equals true. Yeah, so maybe like I shouldn't set that, I don't know. Okay, so like standardize lower and strip punctuation. That's what I want. Learn strict punctuation. And split. Yeah, like we wanted to split on like character. Engrams. Ignore output. Do I have to say output mode int? Okay. Well, what are the other options? Multi-hot count. Yeah, okay, so we'll just say int. Because I think it's like you output the output of this layer feeds into the embedding layer, which actually will give you like three-dimensional floating point vectors like for each character. And then I think like when you run training, like it adapts the, or like it learns the embedding vectors, which is like unsupervised learning, kind of. I guess, yeah, I mean, that's like, is that like clustering? We'll just say it's like clustering. Okay, so integer. All right, what else do I need here? Output sequence. Okay, I'm just gonna do this last. Output sequence length. See, I mean, this is the thing that confuses me, because it's like, I know what the vocabulary is. It's the characters. Okay, so we'll just say output sequence length. Whatever this is, 5, 6, 7, 8, 9, we'll say 20, because who cares? Okay, so that's like a vec layer, and then we have to do all this stuff. Okay, so, okay, we have to create a model. Keras.models. Sequential, and then input. Okay, so we had an input layer, which I guess is separate from the vectorization layer, and then we had the vectorization layer, which we called vec layer, out of an economy of typing, you know? And then then we have to like input stuff. Yeah, okay, so let's see what this does. You can just okay, so where does it use text data set? Like, where does it use that? Oh, you have to adapt. What does this 64 mean? Oh, it's the batch size. Right. Okay, let me see what that does if I call it on this sentence. Sentence batch 10. What does that do? I have no idea. Print? Yeah. Yeah, I don't know how to use this. So, alright, so we'll run the the adapt thing. Like, this doesn't seem like this is how you should do it. This seems terrible. sentence dot batch. I mean, what's my batch size? I don't know. 19. What's that gonna do? Well, we don't know. Okay, and then okay, so I'll just run this stuff, and then and then we'll say, you know, oh well, like if it's getting the vocabulary from this, like it's not, there's going, yeah. Well, we'll just run it on those, whatever. Okay, so let's see what that does. Wow, the documents are out of date. Oh, I spelled it wrong, actually. Cool. Sequential. Sequential. Yeah. Oh, shoot. It did something. Okay. So what did it do? So it's we're passing it in this guy. And so I guess it's saying like 1 is the integer for unknown, I think, because I don't think that integer, there is no f in the training data set. And then, or O, so then 4 is space, and then unknown, then 4 is space, and then unknown, then a 10, yeah, so like it assigned the character A the integer 10. Also, what is this warning saying? Tracing. Okay, I'm just gonna ignore that. I have no idea what that's about. Okay, but so like it kind of did something. Yeah, it kind of did something. My thing is like, I shouldn't have to, I don't think I should have to adapt. Like, I think if I supply the alphabet or the vocabulary, yeah, there's no need to adapt if you supply the vocabulary. The vocabulary is just A, B, C, D, etc. Okay, so either an array of strings or a string path to a text file can pass a tuple list. Okay, I know there's a way in Python to get like a list of the alphabet. So we'll just see what that is. Yeah, how do I get alphabet in Python? I mean, okay, by the time it takes me to search this, I could just type it out, I guess. Yeah, that's what I need. Perfect. Okay, so I'm going to import the alphabet. And then this has to be like a list. I can handle that. No, I'm not gonna know how to do that actually. Okay, so let me figure that out right quick. Import string. Done. Okay, and then that gives you a string, and then I need to make each of those like a list or something. Oh, it worked. Okay, never mind. I didn't think that would work. So, and then that's the vocabulary. isn't it? And vocabulary is like that. And then we don't have to adapt anything. Yeah, but also, don't you want like a space? Yes, I think you do. There's your space. And so what does that do? Oh my god. Attempt. Oh. Oh. Fair. Can I, like, not have that, or... Oh. Okay, listen, I'm gonna count this as, like, a successful live stream. So, we got this, text vectorization layer to output, I mean, these aren't, like, one-hot vectors, but, like, you can pass these... So like, the thing we'll do next is, you pass this array directly to the embedding layer, and then the embedding layer like performs the lookup of like, this character f has integer 7, and then integer 7 is associated with a floating point vector of arbitrary dimension. And so the embedding layer like outputs those the embedding vectors, and then what we're gonna do, which is not what you should do, we're gonna take all those embedding vectors and we're just gonna concatenate them like end to end, and then we're gonna pass them into a fully connected neural net. And then we're going to train the neural net to do character prediction using text. And it's going to be awesome. Maybe.